Okay, I want to do a video for section 8.7. It's not a difficult section, and that way we can spend our limited class time on doing more important things. All right, so let's take a look. Let me change this. We'll try that. Okay, so let's take a look. The big idea here is to recognize that if you have something like something raised to the 1/2 power, that it means the exact same thing as the principal or positive square root of a. The big thing to notice is that the denominator of the exponent, the fractional exponent, winds up being the index of your radical. So if it's to the 1/2 power, that means a square root. If it were a to the 1/3 power, that's going to mean cube root of a. Okay, so the denominator tells you what kind of a root you have. So some of the problems you might be asked to do will be similar to what you see on questions 1 through 3. Convert the expression to radical form and simplify if possible. So 25 raised to the 1/2 power, that then means the same as the principal or positive square root of 25, and we know that's 5. So your answer to that question would be 5. All right, now question number 2 is a bit harder because it also throws in negative on the exponent. And so then you have to go back to remembering things like this. Like if you had x to the -2 power way back when we were doing exponents, that would turn out to be 1 over x squared. So the negative exponent causes you to take the reciprocal, to do 1 over x to the 2nd power. So if it's the first thing you're going to do, if it's a negative exponent, is to think that's going to be 1 over still 16 raised to the 1/4 power. So that's going to be 1 over, that'll be the 4th root of 16. So the denominator matches the index. And then 1 over the 4th root of 16 would be 1/2 because the 4th root of 16 is 2. Since 2 times itself 4 times would be 16. So that one, I think the difficulty there is mainly the negative exponent. Now this one has a negative, but it's not the exponent. It's part of the base. Okay. The denominator of the fraction is 3. So that tells us we're doing a cube root. -27 is underneath the radical. And then the cube root of -27 would be a negative number. That's what we talked about. If you have a negative under the radical and this is odd, you're just going to have a negative number, and then the cube root of 27 would be 3. So -3 would be the cube root of -27, and that would be your final answer. Okay, notice number 2 was not a negative number. A negative exponent just causes you to do the reciprocal, okay, to do 1 over. Right now, all that's going on in this next section is we're going to have something instead of just a 1 on top of the fractional exponent, we might have a number other than 1. Okay. The numerator of the exponent is going to wind up giving you whatever the power is, whatever you're raising it to. The denominator is going to give you the index of the root. So for instance, if you had like 5 to the 2/3 power, then you know it would be a cube root. 5 is the base, and then you could either square it after the fact, or you could have squared it first, okay, and then taken the cube root. It could go either way, okay? So when you get to doing these, what you're going to wind up doing is setting up your radical. The denominator is 2, so you know it's a square root. 9 is the base, so we're going to put it underneath. And I think doing the root first is best, because then you'll find out if you have any of those special situations where something is not a real number, you find that out sooner. So I think it works well to do the index first. All right, so on this one, I'm going to do the square root of 9, then I'm going to turn around and cube it. Okay. So notice how the top number gives you whatever the power is and how the bottom number tells you what the index is. Okay, and then 9 was the base, so that was why 9 was under the radical. So this would be 3 to the 3rd power, and that's going to be 3 times 3 times 3, so the overall answer should be 27. Okay. All right, now here we're going to wind up doing 0.09. We're going to square root it, raise it to the third power. And you can do the square root of 0.09 on your calculator. It'll be 0.3. And then when you cube that, you're going to get, let's see, I think that'll be 0.027 because it'd be 0.3 times itself 3 times. So you should have 0.027. Could put a leading zero in front of that as well. Okay. All right, now let's look at 6 and 7. So on that one, on 6, we have a negative in front. It's not part of the base. So as I set this up, I'm going to do cube root of 27. I'm going to square that. And when I'm finished, I'm going to take the opposite. So the cube root of 27 is 3. Okay, I need to square that first before I take the opposite in this case, because the negative is out in front of those parentheses. So I'm going to do 3 and square it, which would be 9, and take the opposite, which would be negative 9. Okay. All right, let's set this one up. So we're going to have the index. You should try it. You can pause the video and try it and then check. We're going to have the index in here. Okay, we're going to have the 32 underneath. Oops, I forgot about the fact it was a negative exponent. So let me slip that 1 over. Okay, so I'm going to do, let me do that one, start that one over again, because you really should consider that negative exponent first. So let me just write it out better. So that's going to equal 1 over 32 to the 2/5 power. Okay, and then that's going to mean that I'm going to have a 5th root of 32 and then square it. The 5th root of 32 is the number you can multiply 5 times. I'm thinking this to get 32, and I know that would be 2, and I have to square it. So I'm going to wind up with 1/4 on that one. Okay. All right, let's look at just a few more here. They're just asking us to convert. It's got the variable in there, so we don't need to wind up doing much simplifying, and then we don't have to worry about absolute value or things that turn out not to be real. It's just practicing, making sure we're paying attention to the base. So 2x is the base, so it's going to be under the radical. And then when we're finished, we're going to square it. Okay, and that's all you do on that one, on number 8. But when you get to number 9, only x is being raised to the 2/5 power. So we're having to go back and kind of recall how things worked with exponents. And it was so important to pay attention to what the exponent was getting applied to. It gets applied to only what's immediately preceding it. So on this one, we're going to do the 5th root of x. Okay, we're going to square that. And then when we're finished, we're going to multiply by -2. Okay. All right, on number 10, we've got the 3/2 power. We've got all of this under the radical. So we're going to do the square root of 9y to the 6th, all raised to the 3rd power. Now that one we could do some simplifying on. They really didn't say we had to, but I think I will. This one you can't simplify, okay? This one you can't simplify anymore, really. But on this one, we really could. So let's go ahead and do it, because we could take the square root of 9 and we'd get 3. The square root of y to the 6th would be y to the 3rd. And then we're going to turn around and cube all that. So we're going to wind up with 3 cubed, which is 27. And then remember, when you cube, when you raise y to the 3rd power, you would multiply exponents. So you would get 27y to the 9th. Okay. Now we're going the other way with it. So on this one, we're changing it in the other direction. So it's important to pay attention to the base. This number 2 is just going to be kind of out in front of everything. The 7x is going to be raised to the 1/3 power. We need the denominator to match the index. Okay. All right, now here, the radical on number 12, the radical sign stops on the 6. The x to the 3rd is really just after the fact, so it's kind of out in front. So on that one, the 6 is raised to the 1/4 power, and then you just have that x to the 3rd sitting there. Okay. So I guess that's all they would like us to do on that one. Okay. Now on this one, the a squared plus b squared is underneath the radical. The radical is a square root. We'd have to have that in parentheses raised to the 1/2 power. And that 1/2 cannot be applied to the a squared and the b squared separately because this isn't multiplication, it's addition. So even if we were asked to simplify, this would be as good as it would get anyway. Okay. Right, and notice on number 12, if the x to the 3rd had been under the radical with the 6, okay, so this is a what if. So I'll do it over here. So what if, this is not what it was 4th root and it had the 6x to the 3rd all underneath like that, then it would be 6x to the 3rd raised to the 1/4 power, and you could apply that exponent to both, and this would have been the case. Okay, that's not what the problem said. The radical didn't go over the x to the 3rd, so that's why I didn't do it that way. But that was just what if it were like that. Okay. All right, and then one more concept we got to touch base on is just a reminder of some of the things we learned. You know, we learned things like when you're multiplying powers, you can add the exponents. When you're dividing, you can subtract them. If you're raising a power to a power, you have to multiply. And that if you have multiplication or division, you can apply the power to each of the items. Okay. And then we had that reminder about a negative exponent. I usually do it like this, but sometimes taking the reciprocal of the base first is helpful. And then if you raise something to the 0 power, you get 1 as long as a is not 0 itself. Okay, so this one is asking us to simplify these expressions that have these fractional exponents, and then they want the answer to still have exponents when we're finished, just fully simplified. So like here, we're multiplying two powers that have the same base. So we should be thinking this, that we can add the exponents. Okay, like that. So that this gets combined. So that would be x to the 10/5, and x to the 10/5 would be x squared. So that would be the answer to number 14. Okay, on this one, we're raising a power to a power, so those should get multiplied. So we have 4, and the work we should do is 2/3 times 6, and 2/3 times 6 would be 4. And I'm going to write it as 4 to the 4th, but because that's like small enough, you could actually do it. You might also simplify that by raising 4 to the 4th power. I don't have my calculator with me, but you would just do that. So 16 times 16. And what is that? Is that 2? Anyway, I'll come back. I'll grab a calculator and do that and finish that up in a second. All right. And then here we would, since we got the same base and we're dividing, we would want to subtract the exponents. Feel free to use your fraction keys on your calculator. You would need to get both of these fractions to have a denominator of 10 if you're doing it by hand. So that would be 8/10 minus 5/10. So that would be c to the 3/10 power. And they asked us to leave it with positive exponents, so we're not going to change it into a radical. We're just going to leave it like that, c to the 3/10. All right. And then on this last one, we have a product being raised to a power. So that means we can raise each of these to the 3/2 power. So we would do that. And really, I would normally just go ahead and multiply that out. But it's been a while since we did this. So I wanted to remind you of what I'm doing. So these would get multiplied. These would get multiplied. So this would be a to the 3rd. This would be b. And on that one, we would wind up having a negative 12 halves, which would wind up being a negative 6 when we're finished. And then it said write the answer with positive exponents only. So I would go on from there and take a to the 3rd over b to the 6th. And they wanted it with exponents, so I wouldn't change it into radicals, and I would just leave it like that. And on this one, in case when there's numbers, they might want you to do it. Let me just do it real quick, make sure I'm right. So that's a 9, a 6, and a 1. So 256. I should have known that. So that's 256. So I would think that they would accept either this, since they told you to write it with positive exponents, or this. Okay. All right. And that's all there is to section 8.7. So it's not a big deal. If you could just watch that video, I think that would be really helpful. And then we can focus on reviewing and making sure we're good with the other sections in that chapter. Okay. Hope this helps.